Okay, so I'm going to go through the last 4 questions that I said I would go through from lesson the other day. So questions 22, 23, and I think 25 and 26. So, a cycle race in France is 2,214.5 miles in length. Miguel knows his average speed from previous races is 21.14 miles per hour. For this next race in France, he is planning on cycling 9 hours per day. Estimate how many days Miguel will take to complete the race. The keyword here is estimate. This, remember, is a non-calculator paper. They do not want you to work out the exact answer. They want you to take a sensible decision. Usually, when we're estimating, we ask for one significant figure in our rounding, because if we're estimating, that means we are rounding our values to make them easier calculations. It doesn't always have to be one significant figure. It's something sensible, and one significant figure often is, but it doesn't always have to be. So what I'm going to do is I'm going to choose to round each of my values. So 2,214.5. Well, that's approximately 2,000 or 2,200. So one significant figure would be 2,000. If 2,200 is a sensible answer, like it's an easy calculation, you can do that as well. 21.14. Well, that's approximately 20 miles per hour. You could say 21. Again, it depends on the calculation. So we're estimating how many days Miguel will take to complete the race. Well, we have the distance, we have the speed. And we want to know how many hours it's going to take him to travel this time. So we need our speed, distance, time formula. I always automatically write it down as speed is distance over time. Now actually what we need to know is the time. We need to know how many hours roughly it's going to take to do this. So time is distance over speed. So you can times by time, divide by speed. Ultimately, if you're not finding distance, it's always at the top. So I want this one. So the time is going to be approximately equal. Well, these seem sensible numbers. 2,000 miles divided by 20 miles per hour. You don't have to put the units there like that. I'm just sort of reminding you what it is we're working out. So 2,000 divided by 20 is 100 hours. So it's miles divided by miles per hour. So it's 100 hours. 200 divided by 2, 2,000 divided by 20. 100 hours. For the next race in France, he's planning on cycling 9 hours per day. Well, you could divide 100 by 9 and get a rough answer, because that's actually not a horrendous calculation to do. Because you do 9 into 100, 9 into 10 goes 1, remainder 1, 9 into 10 goes 1, remainder 1. And what you'd soon find is it's 1.11111, which is approximately 11 days. What you could also do is say that 9 hours per day is approximately 10 hours per day. And do 100 divided by 10, which would be 10 days. Now that seems strange because there are 2 possible answers. Actually, there's a slightly wide range of possible answers. And it may well be that MathsWatch didn't necessarily give you the right choice, because MathsWatch is quite limited in how it's programmed. But it shows you that depending on how you round it, you can get a slightly different answer. Because that is already one significant figure, and that would be an appropriate estimate to do. However, you could also do this and get yourself that answer. But the main thing here is, one, that you're rounding, not doing the calculation properly, and two, that you are using the speed distance time formula appropriately. So that's question 22. Question 23. So here is a solid square-based pyramid. The base of the pyramid is a square of size 12 centimetres. The height of the pyramid is 8 centimetres. So you can see in the diagram the height, that's that bit here. So literally from the base directly up to the point. X is the midpoint of QR and XT, and is 10 centimetres. So Q X is the midpoint of QR and XT, T is up there. Sorry, I didn't print properly. XT is 10 centimetres, so this slanted height is 10 centimetres. Work out the total surface area of the pyramid. Now, actually, this question is slightly less challenging than the one that you're going to get in your DIT, but that's because we've got some harder things to deal with, and I'll talk about what your DIT activity will be related to. So X is the midpoint of QR, and TX is 10 centimetres. Work out the total surface area. So that is the sum of the area of all the faces. So we've got face number 1, which is the base. Now it's a square-based pyramid with a side length 12 centimetres. So the base is 12 times 12, which is 144 centimetres squared. The second one, you've got the triangle sides. And there are 4 of them. Because what you're doing is adding all 4 of these faces together. So if I took just one triangle side, so let's look at QRT X. So I know the base is 12 centimetres and the height of this triangle is 10 centimetres. So the area of that is half times 12 times 10, which is 6 times 10, which is 60 centimetres squared. There are 4 of those because each side is the same. So 60 times 4 is 240 centimetres squared. 6 times 4 is 24, add the 0 for speed. So 3 is you're going to find the total sum. So 144 plus 240 is 384 centimetres squared. Now on your DIT, you're not actually given, it's in the real exam paper, you're not actually given that information. So in the exam, quite often you wouldn't be given that information. You would need to use Pythagoras Theorem to find the slant length of the triangle, because you need to know the height of that triangle, and the height of that triangle is from the bottom, the base of the triangle, up to the top of the triangle, not the base of the pyramid, the base of the triangle. So if you didn't know that, you would need to use Pythagoras Theorem. So that's T, that's sort of the centre of the base, that's X. You know that this is 8 because you're told. That's halfway across the bottom. The bottom's 12, so that's 6. And you want to find xt. So xt squared is 6 squared, add 8 squared. Xt squared is 64. 36, add 64. Don't forget that the right way around. Xt squared is 100. So therefore xt is 10. So this would be the extra step that quite often you'd need to do in an exam. In this question you did online, you didn't have to do that step. However, on the version on Desmos that you'll be working through, you will have to do that step. So you'll have to use Pythagoras first. For this question, you 100% need pen and paper when you're doing this question. You can't do this just in your head. There's no way you can do this question just in your head. There's too much information, so you have to use pen and paper to work this out. So that is that question. Question 25. I left out 24 because it was just bonkers hard. So I thought it's not for today. That's for a time we're in lesson. We've got more time you've got more time with me in class to do that. So skip that and do 25. P and Q are points on the line y equals 2 minus 4x. Complete the coordinates of P and Q. So these are substitution questions. So coordinates are always in the form x, y. So when x is 0, what is y? So y is equal to 2 take away 4x. We know that's the formula. So y equals 2 take away 4 times 0. 4 times 0 is 0. So 2 take away 0 is 2. Q, we're solving this, but when y is equal to 0. So 0 is equal to 2 take away 4x. This is hard, but I'm going to add 4x to both sides. 4x is equal to 2. So divide both sides by 4, which is the hard bit. Dividing by 4 because it's 4x. 2 over 4, which is half. Plot the points P and Q on the graph. Use the X tool. Well, we haven't got that. Plot P and Q on the graph. So 0, 2 is there. And then half 0 is there. Then says draw the line y equals 2 minus 4x for values of x from minus 2 to 2. Well, when we draw lines, there's a range of ways we can do it. Either we can do what we've done here. So for part C, method 1, find where it crosses the x and y axes and draw, which is what this one has. We found where it crosses the x and y axis. We draw the line through, put our ruler through, and we draw the line. But if we find substitution hard, then that's hard. Method 2, we could find the y-intercept and then use the gradient to help us. The y-intercept is the bit without the x. So the y-intercept is 2. So it crosses the y-axis at 2. The gradient is negative 4. So that means if I go across by 1 whole on the scale, so that is 1 whole, I would go down by 4 on this scale. So 1, 2, 3, 4, because each square on this axis is 1, each square across on this axis is 1. So that's a point on the line. Across 1, down 4. Plot those couple of points and then draw my line through. Method 3 is a table of values. So you know here what you've got. You're going to draw yourself a little table of values. Often you're given this, but you're not always. So you've got minus 3, minus 2, minus 1, 0. You don't have to do all of them, but you may want to. And you're going to use the formula y equals 2 minus 4x to substitute this in. So when x is 0, 2 take away 0 is 2. When x is 1, 2 take away 4 times by 1 is 2 take away 4, which is minus 2. When x is 2, I know I'm going into this question. 2 take away 4 times 2, which is 2 take away 8, is negative 6. And you do that for all of these values, and then you plot the points. In the DIT work, you don't get part A and B. You just got straight to that line. But this question is structured to give you that sort of support to get to drawing that. So you've got a sketch tool online. Use one of those methods to see if you can plot that line. Finally, vectors question. You did this during the lockdown when we were first going into school. So for those of you that attended, you'll know this. If not, it's something that we will need to revise. A is 2, 4. B is 3 minus 2. These are vectors. So this tells us, if I was to draw this line, it goes across 2 and up 4. This line here goes across 3 and down 2. Not that massively matters, but it's to give you context of what a vector is. It's basically a line showing a direction. Work out 3a plus b as a column vector. Well, 3a plus b is equal to 3 lots of a plus b. 3 lots of a, well, I'm actually just going to multiply like I'd multiply anything. 3 times 2 is 6. 3 times 4 is 12. Add b. 6 add 3, 9. 12 add minus 2 is 12 take away 2, which is 10. So 9 at 10 is our answer. And that is it. So that's quite a nice one to finish on. So now I'm going to get you to do is to log on to Desmos, and you are going to complete the DIT activities that you started on Tuesday's lesson, and you'll finish off today.